Hello and welcome to another video. Euclid Gonzalez here. Today we're going to talk about observables, a quite interesting mental model, especially when you need to handle is streams of data. Usually, data that you need to wait for that, and that you want to actually is plug into that. And this observable, which is follow this behavioral design pattern, the observer design pattern, which is the way of how can we now subscribe or plug in to events emitted by a subject. So a good example of this is a celebrity. So let's say, I don't know, Messi, LeBron, Taylor Swift, Putin, the Trump, you name it, right? Millet, someone that you want to actually follow and receive frequent updates based on what they're doing. So, this particular mental model that now when we talk about in the JavaScript or in the language aspect is that this is something that, unlike, for example, collections of data that we know the fixed length of that, this type of data is now data that comes in time. It's data that we're gonna discover how now Kyle Simpson actually mentioned and described that. So we can have now this concept, this understanding, so we can now apply that to our real life. At least to understand is what are the most common methods that we can benefit from it, especially and useful for handling user inputs, right? So, for example, when a user is clicking a lot of time into that in a bottom, and how you can actually is by using this particularly library, RxJS, how now they made up this possible, so we can now is have a much more fine control of what are the type of data that we want to work with as we receive this in these streams of data. Let's get into this. Let's definitely get into this.
Move into
Because now we're gonna take a look at the event plus promises, right? Event plus promises. Interesting. Remember that at the end of the day, promises is this idea that we need a placeholder to eliminate time as a concerning factor, wrapping around a value. The TLDR of this is you can think of promises like an event listener. That by the time that you get that data, and you're gonna get this data once because this is something that is fired once, all right? You can actually work with that data by subscribing to a listener event .then, all right? And then you can actually operate on that data. Or if there is an error, you can subscribe to the .catch. So you can now handle errors in there. So this is great. This is huge. This is powerful, all right? Because especially when we are going to look at how can we handle these streams of data, all right? For data that we know that we're gonna call once for Ajax requests, which is great, right? We know that this data it can be in two possible states. It is a failure or not, all right? But what happens when we need to handle is streams of data for a server or for any other source, right? What is the source of truth here? What happens when the source of truth becomes now a producer of this series of data, this chunk of data that is sending, okay? How can we handle that, right? Because at the end of the day, promise is resolved once, okay? But you want is to actually is now try to find a way to handle that anytime you click here, right?
some really brain-bending stuff. Okay? Time to move into some
So time to move in to some real mind bending stuff. Okay.
Really brain bending stuff.
Brain bending. Okay. Mind bending, brain bending. Brain bending.
Okay? If you thought the stuff what we went over was brain bending,
if you thought that promises and generators was mind bending, wait to see.
buckle up your seatbelt.
Was mind bending, buckle up your seat. Buckle up your seat.
Okay?
Okay?
Concurrency, that's what we've been talking about.
There you got it. Okie dokie.
This entire workshop, right? What was a poor man's definition for what I meant by concurrency? Basically managing the flow control, managing all these things that are happening and responding to things in the proper order. So
responding is the coordination of all of the things in the proper order. But this is a lovely.
Basically managing concurrency, that's what we've been talking about this entire workshop, right? What was a poor man's definition for what I meant by concurrency?
Mm-hmm. So this workshop or this course is all about concurrency. In a poor way to describe it is a way to coordinate response in order, right?
Basically managing the flow control, managing all these things that are happening and responding to things in the proper order.
Describing is a way to coordinate response in order. Managing flow control. Managing flow control.
So we know that promises work when there's a single request and a single response.
Mm-hmm. So we know that promise responds when there is a single request and a single response. Okay, it's unitary, right? So we know that promises responds that promises respond when there is a single request and a single response. Okay?
What happens when the source of our information that's coming is actually a repeated stream of information?
Mm-hmm, which is exactly what we're doing. So what happens when the source of our data is a repeated stream of data?
It's coming. Can we wire promises into an event stream, for example?
Can we wire up an event listener? Can we wire up a promise? A very interesting question. It all starts with a question, man. It all starts with the question. And what happens when the source of data is a repeated streams of data?
of our information that's coming is actually a repeated stream of information that's coming.
It's a repeated streams of information. The question is fantastic. The question is fantastic. So what happens when the source of data is repeated streams of information? Do we wire up a promise to that? For example, events, all right? And here where we have these notions of the event loops and all that kind of stuff.
Can we wire promises into an event stream, for example? Because frankly speaking, if we really look at it, most of the asynchronicity that's happening in our programs is actually event-oriented. All of
because if you think about it, most of our asynchronicity in our program is about event orientated.
our UI is. Frankly speaking, if we really look at it, most of the asynchronicity that's happening in our programs is actually event-oriented. All of our UI is almost entirely event-oriented.
All of our UI is entirely event-based orientated. And that's true. And that's true. Because that's one of the reasons why I'm actually here. Especially take a look and understanding is what Redux is all about, which is this particular monad concept, which you can describe that in terms of its functionality, or one of its functionality. That is, hey, this is now a way of modeling is state change. And when you talk about modeling is just a way of how we can describe state change. Okay? So can we write that? So, but again, because we went into the Redux API and understand that after all, this is a closure that actually is now exposed certain methods that when we want to now update the state, we need to pass through this flux architecture by defining its actions and then a reducer. That a reducer, we're gonna take now your actions with a payload, and then this reducer, which is just a fancy say to say, hey, I'm going to now is take this data and I'm gonna return something that is a single output, a reducer. So Perplexity here can help us here, or Claw, right? In our way, right, to do is this, to say, hey, it is safe to assume that the term reducer from functional programming, I prefer to make the mistake and then you correct me, because in this particular loop I actually can learn a lot. So it is safe to assume that the term reducer from functional programming is a way to generate a single output based on an input. Not exactly. Let me clarify what reducer is in functional programming. A reducer, also called reducing function, takes two inputs, an accumulator and the current value being processed. It combines them it combines them according to some logic to produce a new accumulator value. And this process is repeated for each element in the collection, reducing the collection down to a single value. Exactly. But it's applying this particular logic. It makes sense. So it is applying this particular logic based on the accumulator and the current value, and in this case is the actions and the current value, That's where you have the actions and the state. So you define a logic to produce or to reducing the collection to a single value. Think of it like a snowball rolling down a hill. Each time it hits some snow, the current value it combines with the make a bigger snowball, which is the accumulator. And that's a very good way to put it here. I actually, because I'm not exposed to that snowball, snowball here, a YouTube video. I never saw that. I never in my life I saw that. Yep. What? Man, it's just a snowball. It's a snowball. Snowball. Wait, what? Snowball. Snowball. In mountain. Right? Yeah, I just want to take a look at that. Snowball. Sky snowball.
No! No!
Oh shit. Oh my god.
I'm okay. I'm okay.
Jesus French toast, bro. It was quite. Oh no, 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 not at all. That was intense. Oh my god. A snowball. All right. Jesus. Anyway, yeah, snowball. Oh crap, man. No, but I wanted to see a snowball forming, bro. Oh, he was part of that? Jesus. But in any case, it's a snowball, right?
No! No!
Shit, man.
No! 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 No!
Fucking hell.
No! No!
Damn, son. Alright, that was. And then your body's trying to survive. Oh my god. Anyway, okay. Well, that's a snowball. Oh my god. But I haven't seen it. Well, that was a snowball in real life. Okay. But again, going back here to the reducer, which you can think of this as a snowball that it now takes the new state. That now the accumulators is the previous state that it has with now the current value of this. The previous, and then when we roll that, when we apply some part of a logic, okay, to return its a new output, okay, we actually now accumulating that, and so on and so forth. This is a good analogy here of the snowball. But here, the reason again why we are looking at this particular concurrency here is because now Redux, which is a closure that actually needs to handle, that exposes a certain API that allow us is to modify the state of an application. And inside of this closure is what it's going to now manage is in its own state, all right? And that's what you require careful programming to do that in its own state. So React at the end of the day, especially hooks, are a closure behind the scenes. So you can think of this, so we can ask here, it's safe to assume that hooks in React is a closure. Yes, that's correct. So React hooks heavily relies on closure to maintain the inner state and reference for that. So you can think of this hooks, all right, as some sort of way that you define now a function that returns another function, all right, to actually is to expose now two property here. So so you can create your own custom hooks for that, right? So you can create your own custom hooks by saying is, hey, let's go to define is a function called use state, all right? That's gonna receive is an initial value, all right? And anytime you create now a hook or you call this function, it's going to say, hey, what is the name of this function? You can say it's going to say is a state, all right? That'll be the initial value, all right? And followed by the function, all right? Where this function will now be called is set count or set state. So what this function gonna do behind the scenes, all right, is to say, hey, anytime I am called with a new value here, I'm just going to simple is call the state, okay, and attach this new value. Pretty much that, right? This is exactly what it's doing behind the scenes, right? It's attaching this new value and this new value and this new value and this new value. Or you can also is compound this value. So for example, here you say, hey, let me now return this into a tuple, all right? That is the state, right? That has the state and the set state as it is, right? So anytime you now call this function, you say, hey, say conf count, it's going to say use state here with some value, let's say 60, all right? And then you want us to now is get those state that is as a tuple. You're gonna get is the counter, for example, as well as the set counter, and you want to assign it to a particular identifier. So anytime you say, hey, I want you to now is set counter to 59, all right, and then I call the set counter to 58, and similar here to set the counter to 756, and then I want to now console log is the counter to see what's going on, right? That's what interesting. Set counter. Oh, because God damn it, we are not updating is the proper state. That's what happened. We need to actually have access to the default value. And because this is now to wherever is contextual, which means is we are not actually making use of the state locally for us, we can have this arrow function, right? where we say, hey, whatever we are calling our state, now the value of this is lexical, whatever it was defined here. So now when we do this, hey, what the French does, it say, hey, there was an error here. We are hiring. Oh, okay. That was interesting. That was interesting. Yeah, that was interesting. But in any case, this is not what I want to. You actually throw an error. Unexpected token. Oh my god. Unexpected token, of course, because it's this one. All right. And to make things much more simple, you say, hey, I would like to now is run this, right? So have access to that state, all right? And then assign the value as it is. So I don't want to instead return something, okay? I just want to run this computation. And by the time I do this, it's still getting is the counter. That's quite interesting. That's quite interesting. It's not changing that the way it's supposed to. So my flaw here is so if I define this as a function here, if I define here as a function, okay, where I want to have access to this state, which is the initial state, right? And now I want to is call the set counter, which I'm going to actually export this as a reference. I want to create my own hook, my own custom hook. Okay, exactly. I want to create my own custom hook based on the following go. It's because I need to return is a function. I answered my own question. That's lovely. Yeah. Because the closure is when you actually call that, which means is I want you now to return is a function, okay, that internally when we call this, you're gonna hold the state of that. So it's going to say, you're going to tell to JavaScript, hey, please, I want to hold the lexical environment here. I want to hold now these variables that are outside of there. Okay? And I want to return is now the state and that function reference that you run it. So by the first time you run it, okay? That's right. So by the first time you run it, it'll say, hey, I'm gonna run this user state. I'm gonna pass this state for that. However, exactly, use state is not an iterable because it's like you have to say, hey, I need to call this function twice. to actually create the closure here. All right. To recreate a hook. Yeah, I'm trying to recreate a hook, but I don't know where is my flaw based on the following code. Oh, hello. The closure isn't maintaining the state correctly because you're creating a new scope each time. Exactly. Okay. So the current value here in the use state. Okay. And this is very important because this is also to understand my understanding about that. So you got now a function that say, hey, create a state, or create use state, right? Create a use state function that is going to handle now the current state. Okay, let current state. Okay, and then okay, is once we run this function, which is the create the user or the use state. So once we call this particular function, we can say, all right, now we can have access to the current state. The current state is in an undefined state. We don't know, but we know for sure that we're gonna get some value here. Let's say initial. And this initial value that we're gonna get, we are going to assign to the current state. Exactly, initially, to the current state initially. Hey, if initial, okay. So we're gonna get is whatever we have in the current state, or the initial, right? Why? Come on, chill, bro. So why this is important? Because we can have something previously to that current state as we now updating that state. So here's when we say, hey, set, we're going to define as a function here, to define is the set state, all right? We're now here, now we're going to have access, whether it's with a function or not. In this case, preferably is to use because we are in a nested function, the value of this is contextual, not lexical, all right? So it means that for our purpose, we want us to now define is a function here, okay? An arrow function that is going to receive this value, you know, it's going to receive this value, yeah, that is going to receive the current state that initial, they're going to see it. So set state, we're going to get this value here, and now I want to have access to the current value here. But here, because this variable here, we can have access to that with the current state, okay? now we can say, okay, this is also my flaw here. One of my flaw here is on the scoping here. Okay, okay, because this is the way of how you can have access to these functions if you're using now this, if they are now in a closure, in a function here. Okay, so you say, hey, this current state is equal to the value. We can call this new value. All right, new value. That's the only thing that is gonna do this. You can also console log to see what is the current value. You know, say, hey, state updated to the current value, just for demo purpose. In question, where are we gonna return our tuple? We're gonna do that is, well, by the time we call the user state, which means at this closure or this block level. I mean, at this, wait, what? Oh, I get it. So at this level is what we're gonna return now is, well, the current state as well as the reference from this function, the set state, right? So because it won't work, what we can do here is that after we call this, they create use states and all this kind of stuff, we say, hey, let me now invoke that function. So first I need to create is this closure state. You say create a use state, all right, behind the scenes. That's one of the reasons why I need to call this twice. Okay, you say, hey, create use state. That'll going to now expose this use state, all right, but we need to create this closure that is going to hold that lexical environment, and then anytime we call that function, we can pass some arguments and to now keep track the inner state of this data. So constant user state, we get this, and now if it wants to actually use a state that particularly hooks, you say, hey, 60, right? And this will return now for us is a tuple, because this is something that React defined, that a tuple with the name that we want to put it to reference those tuple, that is counter in our case, or set counter, the setter function. And let's go to now put this will be the label of this tuple that is referencing to those properties inside of this closure. And anytime we say, hey, set counter to 59, all right, and set counter to 58. So console log now the counter, right? And then you say, hey, set counter to 56. They now counter the 56, and then console log that counter, right? So this is not how our brain works. So it will print 58 and then 56, right? Current value is not defined. Wait, what? Oh, Jesus. Yeah, no, you're right. Absolutely. You're damn right. You're damn right. Because it's current state, all right, not current value, and then you got it, right? State updated to 50, 60, and 60, so it's not actually updating that. Oh, 60 still shows 66. We're not re-rendering it. Okay. The real React implementation is more complex because you need to track multiple hooks per component, handle re-renders. Okay, so by the time you call here, it needs to actually keep track of the current state of this. Because we are actually referencing to current state here. And despite that we change internally that, okay, we need to manage is that how we're gonna get that state for that. Handle re-render, manage component instance, deal with concurrent rendering, handle dependency for effects. But again, we now create our own simple version of this state. We know that for sure inside of this closure, right, this jar in your computer, this mini jar in your computer that you put stuff there, and then you know what are the things that it's doing. But that's one of the reasons. Of course, there is more complexity here because we need to actually track is we need to track in re-rendering and all that kind of stuff. But as you can imagine, hooks behind the scene, that's exactly what it is, right? Now, in any case, but this is huge because we get in here into the Redux API as a way to understand how the things work. What is the problem that it tries to solve? And by creating now a closure that's going to maintain its inner state and provide you some helper functions to update that state in a consistent way, all right? So whoever is going to actually try to update that state, they can do that. But following is this flux architecture, right? You need to define an action, and you need to define a reducer, and the reducer is just a fancy function to say, hey, we need an action with a payload, all right, and a state. So anytime we detect that particular state, anytime we run these functions, and we detect these particular actions that we want to perform to update the state, we're going to define now is an if statement here, a table, a comparison table that we can actually is take a look and update our state. Yeah, this is a lot of jargon here. I know that there's a lot of jargon, and there is a reason why actually here I'm exploding is this particular aspect of the asynchronicity and why this is relevant, why this is important, not only for managing your state and how you can create your Redux API from scratch, okay? What is the API that is exposed? What is this particular components like compose, which is something that it comes from the functional programming. And not only that, it's also explore that as you define is your app level state data with Redux, and also is the mechanism to update the state, all right, using the Flux architecture, and how now you can enhance is that particular store, this particular state here, this closure with Redux to, well, verify is how this state change using enhancer, for example, how long this particular action takes to the performance, or what you want to know is what is the logs for logging, for logs, or for measuring timers, okay. But also there is a very interesting thing here, which is Redux say what happened when we need to now update our state, not in a synchronous way, but wait for something to happen and then update the state in a concurring way, in a way that task overlaps at a time. and we need to wait for something to then update that. So Redux say, hey, for those scenarios, I want you to now keep the logic. We want to keep the update logic and the asynchronous logic separated, right? And how can we do that? By using middlewares, which is a computer concept. It's a computer science concept that what it does is to sit between uh, two stuff and do something. So apply some logic. So this middleware, in this case, is say, hey, anytime that someone wants to perform a state update, let's say a counter, okay, let's us now to say, all right, before that update happen, I want you to wait for something to complete, and by the time that is done, then we can update that. So this time that we need to wait for that previously was handled by callbacks, and this is something that is not user friendly, especially when we need to handle now more complex asynchronicity and concurrency in our JavaScript applications. So callbacks fell short to handle this challenge. So that's what we have, and also it has some particular problems in it itself. Not only that we need to coordinate all of this concurrency, which is not a trivial stuff, and also that we need to or that it insert this inversion of control, because with the callbacks, especially with the timers, okay, we need to pass a set of instructions that will be run at some point in the future. So we hopefully, because we don't have certainty of that function wouldn't run too many times, too few times, too early, too slow, too late, sorry, without losing data context or swapping errors and all that kind of wildness, no? So it seems, well, we need to find some sort of pattern that allows to help with that. So that when we have things that we don't have to worry about is time as a complexity or as a concerning factor when we're handling is this asynchronicity. We can use that this way of describing this with thunks, which is it say, hey, let's gonna give us this function everything that it needs. So by the time we call it, we get that. That's all. It's going to wrap this function that everything that it needs into another function. So by the time we call it, we get that value, and this will act like a token. Okay, so we can store this data here. So pretty much a thunk might be is so a good example of thunk might be is that anytime you go to anytime you go to the same shopping mall to get, let's say, anytime you want to buy, anyone you want to do to your grocery store, you know that there is a place that can give you that, right? So anytime you go to that, it has all of the stuff that you needed, right? You just only need to go there and get that, period, right? So the value proposition of thunk is that, but again, we still have the problem of inversion control because we need to pass a callback to this, and also that by the time we need to write our code is again not is much better than we have with callbacks, but still is not reasonable in terms of how our brains plan things. So because of that, we need to find out new particularly pattern on how to help us with that, Promise kicks in and say, hey, I'll be your placeholder that you need to eliminate time as a concerning factors. So you only need to do is call me, or you need to also is subscribe to me anytime you actually get a value, whether it's on fulfill or reject, right? So you can think of Promise as these placeholders that allow us is so these placeholders that we need to eliminate time as a concern by wrapping a value around it. So in other words, you can think of it as like an event listener, right? So by the time that actually happened, in this case, we get the value out of this, now we can do something. And in this case, with the .then, you can subscribe to that by passing is a callback or a function, right? Or the catch. So this now Promise give us now flow control and data flow. Again, the problem that Promise solves, because it provides some all other abstractions to handle this with the concurrency in an application, which is a great thing. So for example is, hey, I want you to now give me a promise that by the time all of them are resolved, I want to get that as it is. So we also look at some couple examples here with Promise.all, where we can actually tell Cloud to generate that. Generate promise, generates exactly, generate firing up multiple promises, generate a JavaScript sample firing up multiple promises, and handle it with .all method, .allSettled, to understand deeply the difference in an effective and efficient way. So you create now your fetch promise, that's right. With the set timeout, you create another one, all right? That both of them are emulating is your promises. So by the time that this already passed here, and the user ID is equal to 2, you say, hey, otherwise return is that. If the user ID is 2, if the user ID is 3, all right. If the user ID is 1, you're gonna get that. If the user ID is user not found, this is user and post not found. Okay. And then you create now fetch user followers. All right. So there you get it. You get now your users, fetch user post, exactly. So your users, your followers, all right, and then some user here for that, right? So you can say, hey, fetch user profile 1, fetch user profile 2, and this. So what happened here is that it's going to return now you a promise here. Okay, example 1, promise all with all successful promises. So by the time you get is this, you can now subscribe to this, and you're gonna get that in the proper order that they were called, right? Which is this. You can say, hey, now the first one, which is the user profile, I'm gonna get is the user profile, and the user profile, fetch user profile. I'm gonna get an ID, the name, and the email, like that, which is here. Fetch user profile, exactly. Fetch user profile. Okay, so fetch user profile, you can now get from the result, in this case, because we are mimicking is this asynchronous behavior, we're not calling to a server to fetch the data, we're gonna get that profile, post, and followers. Fetch user profile. Oh, and look at this. This is resolved last. Fetch users follower. Okay, it's because it's composing all of this data. All data fetched successfully. So you have now fetch user profile first, and then user post, and then followers here. So this is a very interesting example here of how can we handle, and this is part of my flaw here. And let me actually now that I recognize my flaw, let me actually create that, because this is the only way of how you can improve here. That's the only way of how you can improve on something, is to truly understand this, right? So here we create now this particular helper function here. Say fetch user profile. Say, hey, const, so fetch user profile. All right. What here we're gonna get is the index or the user ID, right? So user ID. Inside of this function, we're going to return now a promise object. Okay. This placeholder around these placeholders. That we need to eliminate time as a complexing factor, wrapping around a value. So we want to create a new promise. Okay, so new promise. What this promise will receive is now the resolve and reject. Okay, this is the callback that we're passing here. Okay, so inside of this callback that I'm passing to the promise, I'm gonna say, hey, by the time that 1 second has passed, I want you to do is this. So I'm mimicking is this task that takes some time to complete, right? So which is returning promise, set timeout, and please evaluate this. This must be a callback here or a function here. So please evaluate this set of a statement. So we can say, hey, if the user is a user ID is equal to 2, all right, you're gonna say, hey, this doesn't exist, right? So resolve or reject here, right? We can actually pass a value to that, you know. You say, hey, reject with new error, and then you say, hey, user not found, or right, or well, actually there is no need to put it here else, but or well, return here. You say resolve this with this particular object. We can say, hey, this will be now to improve readability here, user, right? that'll have is now what ID, name, and email. Okay. Okay, that'll be his ID, the user ID, name, say username, say user ID. All right, followed by the ID, name, and email. Right, you say the email will be is user ID at some mail, or example.com, and that'll be all, right? So you're gonna return is this user. So this is for this. This behavior will be pretty much the same for other functions, right? So for example, now fetch, you want to fetch, this was user profile, fetch user post, fetch user post. Pretty much the same here. This is a function here. This is a function. The subtle difference between this function is fetch user post. Again, we're going to receive some user ID as well. User ID. Okay. It's important to understand that when you use this function, the value will be referenced to whatever was called. Okay. So in this case, we actually have the ability to pass down this without the value of this, without referencing to that. Okay. Functions, after all, have the arguments, and the value of this is contextual to where it was called. So by the time we fetch user post user ID, we say pretty much the same. We return now a new promise. Okay, this wrapper, this idea that we don't need a time, this idea that we eliminate time as a complexing factor wrapping around a value by passing now a callback, resolve and reject, where here we're gonna say, hey, pretty much the same as we did in the other line. We just said timeout, right? We want to mimic this behavior. So after 1 second, okay, I want you to now run this particular callback or this arrow with arrow function here, okay, and that is, well, let me now, again, the tag is the user ID. If the user ID is, sorry, so if the user ID is equal to 2, all right, I want to now is reject this. We can make it just 1 line, or that'll be all, reject this with new error here. That'll say, hey, user post does not exist. No. So user not found, user post does not exist. Okay, and we say now, hey, I want to do is this. So if we, otherwise if we pass some other ID that is not 2, all right, I want you to now, just for the sake of this example, create a new user here. In this case will be is post. You can say user post. Here this is user, that'll be good. User post, and this user pose, look at what will be the shape of this. So this fetch user pose, okay. When you want to actually get several pose of this, user pose here will be now a collection here of this element. Where you say, hey, I don't know what will be the structure of this. Can you provide me some structure here? ID title and ID and title. Okay, so ID 1 and title. This is actually not relevant for the case, but is important. So pose 1 by user by user here to actually show who made this. Okay. All right. We actually copy and do the same for this one. Right. 2 title. This is now post 2 by user ID. Okay, this is where we're gonna respond. In this case, resolve with the user post, right? Just like that. And this is just to send a series of collections of posts. So we have now the fetch user profile. We're gonna mimic the behavior of that the server is sending one single object or a collections of objects with fetch user post, and the other is the fetch user followers. Okay. All right. The using is now math_random.1000. Okay. We can also create now some helpful function here. Okay. What we say is function randomized time, right? Where here we're going to is to calculate that, right? We're gonna return now is the math.random, right? Which is great. I think math_random exactly is a function here. Math_random, where we say, hey, math_random, multiply this by 1000. Okay, and I want you to now is give me the natural value from this expression, right? Which is from the model of 8000, right? So this is just a fancy E4. So this was just a fancy way to say, hey, I want you to now give me is the, so because you're going to, we want us to know the left, what was left here, okay? I want to know what's left, I want to know what's left here from this division. And what's left, it only can be from 0 to 7999. From 0 to 7999, right? That's the only part that I want that you can get from this. So it means that this is a good way of representing here is that at least it must take now up to almost a second. That's a very interesting thing here that's going on. So how you can now express mathematically is that you only want is to, whatever factor you are generating is up to seconds here. That's a very interesting thing that we did here. Very interesting here, because it's like, hey, you want to generate random numbers. Good. But for how long? You know? What is the range of those numbers you want to generate? Oh, it's from here. It's from this position here. And you want to, of course, make a long enough, you want to make some long enough numbers to do that, right? Because, for example, if you define is the same length of this number, you're also going to get is 1, and 1, and 1, and 1. So that's a good way of how you can actually is identify that, hey, I want you to now is I want you to generate is this random number up to this point. Randomize time. Or you can say, yeah, randomize random to 8. Randomize time to 8 seconds. You know, is this? So randomize time to 8 seconds. Why I put a 1? Because if the result of this division now give you now a 100 or a 1,000, which 1,000 is now this 8 seconds that represents, it actually going to now be a 1, a unit. So we don't want that. We want it to actually give us the model, give us this model that will contain is the 8 seconds. So randomize time to 8 seconds. Randomize time up to 8 seconds here. And this is what you can put here. So hey, I want you to now call this, because this function is hosted, all right? We can actually is now safely get that. Of course, I want you to run this function, right? And if you actually want to check if I didn't lose my mind, glad we can do that. All right. And that is, well, we can say, hey, randomize time by 8 seconds. Okay. And then we got this. And by the time we actually call that randomize seconds, 3 seconds, 4, that's quite interesting. Milliseconds, randomize that, you get it. You get the idea. That's some mathematical tricks here. Working with the division, how many time left, what's left, and what do we have? All right. So fetch user profile, fetch user pose, that kind of stuff. And now we're going to mimic some other behaviors here. So for example, that this promise always resolve, fetch user followers. Let's say here function fetch user followers, right? So followers, fetch user followers. Where here we're gonna get is the user ID. This will mimic the async behavior, or this idea that we want to that we need a placeholder to put that we need some sort of placeholder to eliminate time as a complexing factors, wrapping around a value by passing here is a callback, all right? That is going to take the resolve and reject, okay, which means that by the time, okay, that is going to simulate this behavior that was going to simulate this behavior and going to return out a promise for us, that it will contain that it will be represent is the completion of a future value. So we say, hey, return new promise here. Here we want to make sure that this promise always returns something, especially randomize like this, okay. And we want it to this function always is return is the resolve is with some data. In this case, user followers, right? JavaScript will complain because it say who the is user followers. Well, it is an identifier that won't be reassigned. That won't be reassigned or redeclared. Okay. Unlike leg, that say, hey, this can be reassigned but not redeclared. And unlike with var, it say, hey, you can redeclare or reassign this. And this is now is function context. You know, this is scope by function. Unlike let and cons, they are scoped by block. So in this case, we're gonna use this. We're gonna tell JavaScript, hey, please, this identifier here, I don't want to reassign. I don't want to somebody else or even myself reassign or redeclare this. And if you do that, please throw an error. So, because this will be now a collections of this particular object here. Okay. So here we got is this one. What? ID and name follower. Okay. So ID 101. In this case, it's a number here. So 101. And ID and name, right? You can say, hey, follower 1 of user 2, So because this is not relevant here, follower 1 to user ID. All right. Again, this particular data is not what we really care about. We want is to now is understand is how the asynchronicity and the concurrency works, especially when we are working with promises. In this particular abstraction, the promise.all settled. Okay. User ID follower 2 of that, and by the time that time has passed, yes, I want to is do this. I want to resolve with that. All right. So showtime, right? Showtime. So promise.all with successful promises, right? So promise.all with all success, right? With successful promises. There you got it, right? So promise.all with successful promises. And here we say, hey, we might want to log that. Say, hey, just to show something to the user here. Promise.all here. Say, hey, promise.all. This is example 1. Okay. Example 1 with promise at all with successful. Good. You got it. Right. Promise at all. Example 1 with promise at all successful. So here we're gonna say, hey, I want to use this static method from promise at all, and I'm going to pass now a collections of promises, and that is, well, fetch user profile 1, say, so fetch user profile 1, followed by the fetch user post here, okay, fetch user post here, and fetch user followers like this, right? So what I'm expecting here, why do you ask? So this is now an abstraction of, instead of us having to deal with all of this flow control, all of these then changeables, right? Because you can say is, hey, I want you to now trigger is this fetch dot user profile, all right, with 1, and then it's starting to now change this, all right. So by the time I get this data, I can say, hey, this is the user profile, right? Profile. I want is in fact here is say something like this, a console.log the user profile data, and then I want to return here now a new promise, which is the fetch user post 1. Okay, that'll be changed, which means that you say, hey, because now this way of how you can define the flow control of this promise, you need to return is a promise to change that, okay? So we can have this chainable dot then, or this flow control over asynchronous operation. So we can say, hey, it means that by the time you return that promise, it say, well, hey, we have this fetch user, we have this, I think it's user post here. That's right. So again, we're gonna do almost the same as this. Where here we're going to show now is the user profile or user post, my bad, user post, and then now fetch here is the user followers, okay, and again change that. As you can see, it becomes quite lengthy and verbose. So you say user followers here, all right, and we got to actually is console.log, and that'll be all, right? Just like that, just like that. Console.log is just user followers, right? Good, good. So instead of actually us doing this, we can actually take a look at the console log here, right? And as you can see, we actually is now printer that data as expected, right? All right. Yeah, just like that. So if we save this, okay, we can say it's now promise, example of promise at all, and user 1, Okay. Fetch user post. Because unfortunately, for that we need to wrap into a promise. This is one of the things here is that you always need to return is a promise here. That's quite sad, even though that we know that we are returning a promise, but you need explicitly to actually return inside of this is a promise here, on this callback here. So for example, you can say, hey, new, before you're gonna throw an error, you can say, what the fuck is new, bro? You need to wrap this like so and say, hey, promise dot resolve, right? And then it's gonna show the user post here. Okay, here is our fault. Okay, good. Promise.resolve here. This actually won't work because we don't understand here. We can say, hey, resolve with 11, right? User post. It's actually passed through this. We can get the data, but when we need to return is a new promise here to change that. No, that's okay. It's okay. I'm singing away. Typing with generators, simulate singing away with generators. No. Concurrency with dynamic programming, concurrency with static promise. I think you got it. But as long as B exactly, which is a get file, it returns a promise. Oh, okay. That's right. So we're returning a promise. Stay with me. Okay. Stay with me. I'm returning is a promise here. I'm returning is a promise. I'm returning is a promise. So this actually works, right? But the second time I call that is might be because I'm returning that. So if I tell you, hey, I am returning a promise here. I am returning is now a promise which is from the fetch user post. All right. I'm returning is a promise here. Hey, please return this promise. Because this is fetch user profile, and I want to return is a fetch user post here. Return. That's quite interesting. It's never getting here. What is the issue here? I'm returning is this. You say, hey, console.log. And always returning is nothing. But by the time I call this, I'm returning is this B2. Okay, and this B2 is this get file, which return is a promise. Okay, that is say, hey, this now is a function with the executor, and well, you're going to now call this like Ajax with this callback that at some point in the future it will now call that. It will now call the callback that I pass here with the fake response URL. So, but in this case, since we are now creating is a new promise here, all right, and this new promise here, unless we are not resolving that, but we do. Actually, let's mimicking this behavior. Here we are resolving that after an X amount of time, similar to this, right? We are resolving that. Exactly. It's like, hey, resolve this with the user post. Okay. And that's right. I want to console.log this. All right. And then return that, which is called the fetch user post. Fetch user post with this particular value, and then wait for that. And once the data is being done, then you're subscribing to that promise here that was resolved. But it's interesting, it's only run only once. Okay. I'm calling this actually worked as expected, right? The problem is that by the time I now running this then, exactly, because this is what generates this promise. So by the time that now I call this, I'm returning this fetch user promise, but unfortunately it doesn't accept me in that way, right? So another way we can say is like, hey, we can define this function like output, right? Where you're gonna receive that data. Oh, wait a single moment. Okay. It's because we are passing is now a promise, but we are passing is that as a reference. We are passing this as a reference. That's what happened. So we're passing here this as a reference. It is passing here as a reference. Exactly, you're passing here as a reference of this. So for example, you can also do this something like this, and this, of course, will work. first text, middle text, requesting files, first text, middle text, and last text. Requesting files, oh, wait a single moment. Okay. But again, when you invoke this, you say, hey, requesting file 2, right? This is because you are doing is that in sequence. This is because you're doing this in sequence. All right. But what if you want to do that in parallel, bro? Okay, this is because you want to do things in sequence, bro. File 1, file 2, file 3. Exactly. So by the time you call here, it now is create this, say requested. Exactly. It's because you're doing, but even though it actually works as expected. Right? Some random delay like so. But in this case, I don't know why this doesn't work. And that to me is quite possible. Let me see if I can do this in this way. By saying is, hey, I want to return is that. Middle text and last text complete. But it's actually working as expected. Fetch user okay. Fetch user post. Fetch user post. I'm passing is this ID. And then inside of this and running is this and say, hey, randomize time up to 8 seconds. This one actually works. But the second time we're calling this promise does not. So the second time I'm calling this promise does not. So you can say, hey, promise 2 of this. Alright. And then I want you to return this promise 2, P2. Maybe this one? A semicolon here, maybe? Alright. It might be, okay. There is something funny here, especially with this. It's like chill. All right, let's going to run this. Okay, that's right. And what's the next one? It's a user post is not defined. Oh my French, though, this is a human error. French toast this. Oh my god. Okay, now this will work as expected. Jesus. Alright. And then you got it, right? That's exactly right. So you got now is this, and is another one, and then at some point is the last one. So let me actually differentiate each one of them, right? You say, hey, this is user. No, what the first does? This is user profile, and this is now a user pose. Okay, and this is now user followers, right? So far so good. You can clear the console here a little bit. You can get the user post, user profile, user post, and some point in the future we get is now user followers, right? That is the way how you can look at this. Look at this. This is the way of how you can now is in parallel call one and then the another and then the another and then the another and then the another. All right. So this is now okay. So this is it. This is promise in series, right? So calling promises or promises in series. Okay, promises in series with successful is this one. So promises in series with successful promise. Now it's promises with all, which is now in concurrency. Promise you can see serial promise. Okay, this will be much adequate. Serial promises with successful, right? Serial promises with successful promises. So far so good. The other is concurrent, which means firing up all at the same time. Promises with all, with the all, and without all method and successful promise. So it's this one. So now this is example 2. Good, example 2. And here the thing is quite different because here we want to fire up all of this. Okay, concurrent promises. Exactly, concurrent promises with all method. Concurrent promises with successful promises, right? So concurrent promises with successful promises. So in this case, we have to do a little bit more manual, which is say, let's go to call this promise 1, okay, and that is the fetch user profile here 1, and then the promise 2 here. They like to use let, but in the case I want these two now not redeclare, not reassign this identifier. So I'm gonna call this now fetch user promise for user post, as well as this. All right. And here we are now triggering is all of this in parallel. So one way to deal with this is to say, hey, promise that one, then let me actually define some sort of helper function here. Say function output, right? You can say it's this one as well. Randomize. Similar for function here. Right, output, what you're gonna get is the data, and just simple is console.log that data. All right. We actually need to rename this one, refactor this one, followed by the output here. So we can say is data here. In this case, it's like, hey, I want you to now output this, right? So call this output, and then this is when things started to get quite interesting. You got the data here, as well as the title, right? Data and title, and then you want to show is in this fashion. You say, hey, I want to show now the title, followed by the data, followed by the data here. So to make our life much more simple, we're not gonna use any of this random stuff here. We're just gonna leave that output as it is. And here, anytime we call this, we're gonna say, hey, please output that. All right. Well, you're gonna receive now the user profile here. The user profile here as the data, all right, followed by the title here, right? This is just to be a little bit more descriptive in terms of what we pass into, right? All right. So you can see something like this. So the whole point of this is that we are defining is a flow of control. And then, hey, I want you to now is to call this another promise here by saying is fetch user pose. Okay, you say fetch user pose with one, and then, okay, after you get that data, I want to now show this data here to that, but because the way how we are getting is this data is not properly, no, because here we need to do something like this. We say, hey, this is the data that we're gonna get. Okay. You see, this is the user profile. What we're gonna pass to this. All right. And then we're gonna call that. And once you get the data, you're gonna pass to the user. In this case is user pose. Okay, and that's what you're gonna pass to this user pose. All right. You are not very okay. It's because of this. There you go. Okay. missing property ID. No, but this output is gonna just run. It's gonna print it out, print out that. It's gonna receive an object with that shape. That's what you're gonna pass to this. Oh, I get it. Similar to this. Yeah, human error as always. Of course, output title and data user profile, output title and data user profile. Exactly. So they're gonna map to that. All right. Because now we are passing is this output title user profile, data user profile here. Again, what is relevant of all of this is that we're calling is this set of instruction with this, followed by the data, the user profile, as well as this. So it means that its object is nested. So it is an object that is cannot be okay. No, again, it's just clarify my ideas. It's just give clarity to my ideas, man. If give clarity to my ideas, bro. That's all what I'm doing here. Give clarity to my ideas, man. You say now that is giving me is this stuff here. Okay, let's go to clarify our ideas. Here what we're doing is to change this, okay? And say, hey, by the time you get that data, I want to now run this, okay? You're not going to return anything, all right? And you're just only going to console log this, the object that I'm receiving here, and this object has the title and the data, and this object has the title and the data, all right? That's what I want to get from this. You can call this as the it's actually accessing to the proper data as expected, right? But by the time we pass now this data user profile, it say, hey, you have some sort of nested object there because fetch user profile, it will return is a single object. Okay, with the shape of user dot user, right? That's what happens. So it's a nested object. You say, hey, now this is undefined. But this is now not able to show the data properly. And not only that, this is showing this. Okay, so this is our output. Do we do this as a way to receive this title and the data user profile? Okay. But instead we can only do is this. Hey, please send the user profile for that. To make our life simple, because this is not about handling this data. This is about showing this data. Say data, right? Showing this data, man. Showing this data. That's the only thing that I want to do here. Please show this data. Okay, this is an object, but at least you're actually showing that as expected. Okay, you say, hey, user, in this case, you have now fetch user post, user post, post in plural, right? That's the only thing that I want you to pass here and render that. Okay, now it do that properly. It means that we're receiving is this object shape here. So it means to convert an object to a string directly. In JavaScript default, string conversion is showing you as an object. But I don't want you to convert this as an object. Okay. Why do you want to convert it into a string? That's to me puzzling. So by default, why do you want to transform that into a string? Okay, that's to me interesting. That's very interesting. Console log that data, right? So template string is actually trying to transform that into a string. Okay, okay, all right. So, but in any case, so we show that, but the other is undefined. It's a fetch user post, and fetch user post now. Because the whole point of this is that we need to return is something, and because he returning is a promise, it's supposed to work without actually having to call this as a function. But it seems it doesn't work like that. That's quite interesting. That's quite interesting. That's quite interesting that you also, okay. That's one of the subtle thing. Okay, that's one of the problems here with when you throw in now a promise in this fashion. You also need to return is a promise for that. Yeah, yeah. Okay. I'm good with that. I'm good with that. So no problem. And then you subscribe now to this. You say, hey, because I want to return a promise, and anytime I need to return a promise, it needs to be done as a function, fetch user followers. Okay, I want, and then I want to actually is giving that data from the user followers. Okay, followers is to say, all right. Now I get this. This is the output user post, right? Output user followers. So far so good, because now the whole point of doing this is to see that we have now this flow control here. That's the whole point of this, is to see that how can we have now this flow control. Hey, once we get this data, we want to run some functionality. And then we need to actually run a promise as a function. And then we want us to actually, with that data, do something and so on and so forth. Well, as you can see here, this is now us doing this in a sequential way, in a sequence, in a serial promise. However, we want to do that concurrently, okay? We say, all right, bear with me, hang on, because here we're gonna use this object called .all, where we're going to run all of this promise at once. All right. Here we have now the promise 1, the promise 2, and the promise 3, right? So by the time that all of those promises are resolved, you're gonna get the results in the order that they were called, and that's something huge, man. Because we don't have to actually handle this concurrency for ourselves. We just only subscribe to that, right? And here we say, hey, we got the results, okay? To be a little bit more descriptive, we say is user profile, all right, and also is user post, right, and also say is user followers, right? So this particular promises will give us is the result in that order, right? So when all of these promises was resolved, when all promises are resolved, you're gonna get the data. However, if not, then you're gonna if any of those promises are rejected, it will reject them. So here you say, hey, this will be the output. All right, we can say, hey, because we want to show that in a particular order, we can say, hey, this result that we're getting here, because we receive that is in an array or in a tuple, which means it's a finite length array where each one of those elements can vary. So it means that, hey, we got is the user, we got is the profile, we got is the post, and we got is the followers, right? All right, and what I want to do is to of course, assign that with a with a variable here with an identifier here to say, hey, please don't reassign and don't reassign and don't redeclare these values or this identifier. Don't reassign and don't redeclare this identifier, which is a good thing. And I want you to just output this to show that. So say profile here. Here we're gonna say is output here. Say is concurrent promise, yeah. Concurrent promise. Okay. And output the post, and then output the followers. Concurrent promise successful. Right, and there you go. So, right, as you can see here in the console log, we got that concurrent promise successful. Okay, it's a concurrent promise with successful, and as a way to differentiate that one from another, concurrent promise successful here. Concurrent promise successful, right? It's like, hey, by the time we get all of this, all right, good. Now we can have access to this. And the other is, but again, the flow control, as you can see here, is using the .den and so flow control and data flow. So this is huge because what happened is, for example, each one of them fail, which is something that can happen. How you can handle? Well, you have now the catch error when that happens. Right? But the other is now, this is another example, like this. Another example 2. Promise.all with one rejection. So example 2, example 3. Example 3. Like this. Alright. And similar to this one, but in this case is the example 4. Right, promise.all with one rejection. In this case, this will be rejected, and of course, this will never get in here. Error occurred, promise.all stop first execution. Error.message. You know, error occurred, promise.all stop at first execution. Like this. You know? And then you have now promise.raise, promise.any to actually handle all of these kind of things. Promise.all settled. Alright. if they are fulfilled, you say, all right, that's a good one. Using Promise.allSettled, when partial success is acceptable, but it's like that. When partial success is acceptable. Fetch non-critical users. All right. When partial success is acceptable. So here we can handle is now our rollback. Okay. Partial set is acceptable is here we can now have much fine control of our rollback operations, of our rollback transactions. So if any of the results, you have now a status of fulfill, all right? So give me is the status, give me is the result status fulfill, and give me the results failed users, right? And then you call this fetch non-critical user data. Fetch non-critical user data. Use it Promise.allSettled. Fetch non-critical data. And let me now wrap this. Exactly. We say function exercise promise all successful. Right? You just only call this, and that's all. And that's all. So here we solve a problem of modularity here. Like this. This is something we're going to do similar to this. Oh, we need to include this because otherwise we'll say, wait, what the French stuff that you think you're doing? That's right. Okay. And then you got another example here, which is pretty straightforward here. And this is for serial. Okay, this is exercise serial. Okay, serial promise successful, right? And you close this, and that'll be all. All right. So, oh, it's referring to user ID, exactly. Ooh. Oh, there you got it. Okay. All right. So I just want to run now is this one. Exercise promise with all reject. You can say is promise 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 all successful. Promise all with reject, right? Serial promise successful, and all that kind of stuff. But again, the idea here is to understand that, right? So fetching non-critical user data, and as you can see, is this one. You say, hey, successful fetch post, right? And this is now calling is a user ID, which is something that you're gonna use a lot of the time. That's right. Fetch user post ID. And now, of course, the 2 is gonna fail. Fail to fetch post for user 1. Fail to fetch post to user 1. This is now more real life scenarios here. Fetch no critical users. Fetch no critical users here. So for example, you have a collection, all right, and from each one of those elements in that collection, you want these to transform them into a promise here, which is something that we also this is true, man. This is true, but we also want to transform each one of those elements into a promise, into an array of promises. And then, okay, by the time we get our results, which will be promises, okay, because at the end of the day there will be a promise. You can also console log here, say hey, console log here results. Okay, all settle results. What you're gonna get is now an object that represents each one of those promises, not their value. In fact, it's our promises here. You're gonna receive is now an object with that status and value, status and reason, status and values, status and values, and status and reason. Right? So that's what happened. So because of this, is now with this Promise.allSettled, we're gonna receive is now, instead of an array of results, much like the Promise.all and Promise.all and Promise.alls and Promise.any, yeah, much like Promise.all, we're gonna get is now and a collections, but an object that follow this particular shape, which is the status and values or the status and reason here in Promise.allSettled. And this is something for partial success. So when partial success is acceptable, especially for handling rollback operations. That's what it is. That's what it is, my friend. That's what it freaking is. That's what it freaking is. That's what it freaking is, bro. That's what it's freaking is about. You know, but this is it. This is just helper functions here. Okay. How to handle serial and concurrent promises. Serial and concurrent promises. Serial and concurrent promises. That's what it is. Serial and concurrent promises. But that's quite huge and interesting. And that'll be all for this video. Take care. Bye-bye.